This is Professor Arai in section 5.2, Confidence Intervals Using Normal Distributions. In 5.1, we learned how to use the normal distribution to find the p-value in a hypothesis test. In this section, we will learn how to use the normal distribution to find a confidence interval. Before we start 5.2, up till now, we've been using the bootstrap to find the confidence interval. So here's a small review about the bootstrap distribution. What we know is that the bootstrap distribution is centered at the sample statistic. We also know that it has a standard deviation that is equal to the standard error of the statistic. And up till now, we've been using StatKey specifically to use the bootstrap confidence interval feature to find the desired confidence interval. So this is one of the examples that we've seen in chapter 3. This is a bootstrap. You can see that it is centered around 60. It has a standard error that is equal to 16.38. Now, if you look at the shape of this graph, you can see that we can draw a smooth line that looks like a bell-shaped, and we can actually look at it as a normal distribution. So we can use what we learned in 5.1 and call this graph a normal distribution that is centered around 60 and has a standard error as its own standard deviation. So we can write the graph names as n parentheses sample statistic, this would be the mean, and the standard error would be the standard deviation. So the previous bootstrap could look like this. Under the normal distribution feature, it's centered around 60. It has the standard deviation. And once we are in the normal setting, we can click two tails, enter the desired confidence interval, and actually create the confidence interval this way. So this is how it looks like using the bootstrap distribution. And this is how it would look like using the normal distribution. Both of them can give you the 95 confidence interval or any confidence interval in that matter. So let's see some examples. Example 1. Using StatKey, find an interval that contains the middle 95% of area in a normal distribution with mean 40 and standard deviation of 5. So let's go to StatKey. So we'll go into normal and we'll edit the parameter to have the mean 40 and the standard deviation 5. Once you create this normal distribution, you will click two tails and make sure that the area under the curve is 95%. So you would write it as 0.95. Once you do that, you will create the confidence interval. So in this case, the answer will be an interval between 30.2 and 49.8. So one more time, the question was find the interval that contains the middle of 95% as an area. So if you look at this is the curve. It contains the area in the middle is 95, and this would be the interval. So again, the interval is 30.2 and 49.8. Example 2 is asking us to find the interval in the standard normal distribution that contains the middle 99% of area. So the word standard normal distribution means that the mean should be 0 and the standard deviation should be 1. So we'll go back to StatKey and click on normal. And once you do that, you have it in the standard normal setting. So we have the mean 0 and the standard deviation 1. We click two tail. So we only click two tail whenever we need the confidence interval. And we change this to 0.99. Once we do that, we will have the interval, and this interval is between negative 2.576 and positive 2.576. So the question is find the interval. One more time, the interval is between negative 2.576 and positive 2 0.576. Example 3, part A is saying find the endpoints. So we're looking at the endpoints, which is exactly as if they are asking us to find the interval. So we're looking at the scale on the number line. So find the endpoints on the standard normal distribution if the area between the positive and negative z is 80. So find the interval or the endpoints in a standard normal distribution where the area is 0.80. So we'll go to stat key. This is the standard normal distribution, but we need the area to be 80. So I'm going to enter 0.80. And the positive and negative z's, remember we call the scale number. Whenever we are looking at the standard normal distribution, we call these values as z's. So here the numbers will be negative 1.282 and positive 1.282. Part B is saying find the endpoints on a standard normal distribution if the area between the positive and negative z is 0.95. So if the area in a standard normal distribution is 95, so I have to change this to 0.95. Find the endpoints. The endpoints will be these two numbers, negative 1.96 and positive 1.96. These examples are very similar to question 34 in your homework for section 5.2. So as with the hypothesis testing, it is often convenient to work with only one normal distribution, and that is the standard normal distribution with mean 0 and standard deviation 1. Thus far, we have connected back to the percentile method, but recall there was another method to find the confidence interval using this formula, sample statistic plus or minus 2 times SE, where SE is the standard error of the bootstrap distribution. The question was, where does this 2 come from? And the answer, it came from the standard normal distribution. So let's see how. When we were asked to find the endpoints, leaving an area in between that is 95%, we found that the z points were negative 1.96 and positive 1.96. And if you round these numbers, you can write them as 2. So we have been actually using 2 as a roundup for this number every time we were asked to find the 95th percentile. And that's why the formula contains 2 in them. We can generalize this idea to use any different type of the confidence interval. So for example, if we want to use the 99% confidence interval, we can go back to the normal or the standard normal distribution and choose the 99 to see what z numbers is corresponding with it. So if we do that, we will find that the z's value will be negative 2.576 and positive 2.576. So we can actually write the formula as sample statistic plus or minus 2.575, if we're rounding, times SE, just to find the confidence interval for 99%. And we can generalize this further. So now to find any type of confidence interval, we can use this formula, statistic, which we can find from the original data, plus or minus z star, which we can find from the standard normal distribution times the SE, where z stars correspond with each confidence interval. So if we look at the confidence interval problems, whenever you decide what number you're going to plug in here, these two values down there are called the z stars, and they are similar to each other, one in negative and one in positive. This way, we can, each time we are asked to find the confidence interval, we can actually find the z stars that capture the middle percent, and then we can use the formula statistic plus or minus z stars times SE. Now keep in mind, we still need to use the bootstrap to find the standard error. In chapter 6, we'll find a formula for that, and we will stop using the bootstrap distribution. Now, these values for Z stars are always constant, so it's a good idea to write them down. So for the 95, we've seen that we've been using 2. The accurate number is 1.96. Whether you choose 1.96 or 2, both of them are correct. The Z star for 90% confidence interval is 1.645, and the Z star for 99 confidence interval is 2.575. So this is how it used to look for us in chapter 3. This is a bootstrap distribution that is centered around the sample statistic. We learned today how to convert this bootstrap into a normal distribution using the sample statistic and the standard error. And we just learned how to use the standard normal distribution to find the Z stars, and from these Z stars we can use the formula. So you have several methods to find the confidence interval, just like how we learned that we have 3 methods to find the p-value from 5.1. So one more time, to find the confidence interval, you can use the bootstrap, you can use the normal distribution, or you can use the standard normal distribution along with the formula. So let's tie up all these information together. Example 4. The mean BMI, which is the body mass index, for a large sample of US adults is 27.655. We are told that the standard error for this estimate is 0.009. If we use the normal distribution to find a 99% confidence interval for the mean BMI, what is the Z star? So if we're using the 99%, we either write down what we just wrote from previous slide. So if you go back, this is the slide that I asked you to write the information. So for 99, the Z-score is 2.575. So you can write that down for this answer. If you forgot this list, you can actually find it from StatKey. You can go to StatKey, go to normal distribution, click 99, and you will see the Z-scores down there. So for whatever they ask you, for whatever number of confidence interval they ask you, you can always plug it in and you can find the Z-scores for this. So going back to the example, the Z-score for 99% confidence interval is 2.575. This includes both of them, the positive and negative. Now find and interpret the 99% confidence interval. So remember, if we are using the Z-score, the Z-star, we will use the formula. And that formula is statistic plus or minus Z stars times SE. Statistic is given to me from this data. This is 27.655 plus or minus the Z star times the SE. The standard error was also given to me. Now, if the standard error was not given to me, I have to use the bootstrap, and we'll see example 5 how we will do that. Once you plug in all the numbers and solve them, you can say we are 99% confident that the mean BMI of all US adults is between 27.632 and 27.678. Okay, let's see an example where we'll need to use the bootstrap. This is the last example, example 5. In March 2011, a random sample of 1,000 US adults were asked, do you favor or oppose sin taxes on soda and junk food? 320 adults responded in favor of the sin taxes. Give 99% confidence interval for the proportion of all US adults that favor these sin taxes. So, since we need the 99% confidence interval, we need to use the formula. The formula requires us to find the sample statistic. We can do that. We need the Z star. We have that. And then we need the standard error. This is the only thing that we don't. We can find it using StatKey. So let's go to StatKey. we will go to Bootstrap. This was a single proportion problem. And the US adults who are in favor of these taxes is 320 out of 1,000. Once you enter your sample statistic, you generate several thousands, and from there you can see the standard error. So now I have the sample statistic, I have the standard error, and I know the Z-star. I can go ahead and plug everything in my equation. So this is going to be, the statistic is 320 out of 1,000 plus or minus the Z-star for 99% times that standard error which we just found, and we have the interval. And we can say that we are 99% confident that between 28 and 36% of the US adults favor sin taxes on soda and junk food. So in summary for this section, if distribution of statistic is normal, you can find the confidence interval using this following formula. Sample statistic plus or minus Z-stars times SE. You can find the sample statistic from your original data. You can find the Z-star from the standard normal distribution, and you can find the SE from the Bootstrap. It would be way much easier for us if we actually have a formula for SE. This way we don't have to go to create Bootstrap distribution. And this will be discussed in detail in Chapter 6. That's it for Chapter 5. Thank you.